Okay, this is rare, but I left a folder at home. I'm really big on turning things back right away, so I've been just thinking about this nonstop all today. I think I get more upset about it than probably you do. So it will be, all your stuff will be back to you on Thursday. I really like to have the feedback to you so you know what you should be doing and if you're on the right page. So what you should have got so far is you're just playing these games. They're getting you familiar with these games. And you'll find as the more you play them, the more you kind of have a feeling or intuition of how to go forward on them. What you should have realized by now is that going and you might have to sacrifice a box in order to win the game. If you haven't won the game yet, keep playing because you should get to a point where you're winning against the computer. You'll have a better idea of a strategy that will get you to win. But today I'm going to go over the mathematical strategy, and it's kind of unusual because the strategy is one that gives you an opportunity to win, but it doesn't guarantee you a win. So it's a little bit different than the next game I'm going to show you, which is NIM, where there is a optimal strategy where you know for sure that you can win in a certain position and you know how to get there. So what you should be able to do at the end of this week is know what I mean by a long chain, what that represents in dots and boxes. I'm going to show you what that is today. There's actually no formal definition that I could find anywhere on what's meant by a long chain. Your book discusses it, but it's not like it is in your abstract algebra book or your advanced calculus book where you have a definition there and they have epsilons and deltas. So that's a little bit unusual, but I think it's a little bit indicative of this field. And the books that are in this field, they're kind of loosey-goosey in some way. They're not defined. In mathematics, that's very unusual. And you should be able to win the 4x4 board by using the winning strategy that I'm going to give you today. We're going to try it. So what's awful about this is you won't automatically win just knowing the strategy, but you'll never end up with 0 boxes anymore unless you really are tired. I can guarantee you that because I've been playing this game nonstop. So I've won it now as second player on the 4x4 quite easily now. I can get there, but as first player, I'm not quite sure that I can get there. So it's interesting to watch it play. And then we'll start a new game called NIM. It looks like they're introducing you to a bunch of games in the beginning, and then they're going to go in depth into the counting. We're going to go into some of the counting today. And on Thursday, we'll go into the concept of something called backward induction. That sounds scary, but it will make total sense when you see what I mean about when in terms of a game. So how you win, you go backward in time and try to figure out what led you to the good answer. So what's the change in dots and boxes? If you're taking notes, I would ask you maybe not to take notes because this is a strange definition. And the reason I honestly didn't give you this definition on Thursday is because I was looking for somewhere a written out explanation with hardcore math language. It's just not there. What a chain is, it's a path that's formed by the interior of the partially formed boxes. I started calling these mazes instead of chains because that made more sense to me. So I gave you a partially filled out board where you can see that me has already filled his box out. What they mean by a chain is this maze right here. You see that I could start in box number 1, see, right here, and then move to this box and move to this box and then move to this box. So I have a little maze where all the borders of the maze are surrounded by lines of the boxes. They're partially filled boxes. They're not complete filled boxes. So that's what they're calling a chain. So that's what they would call a 5 chain because I cover 5 potential boxes as I make this path. This is a 2 chain right here because I cover 2 boxes and it's a maze of 2 boxes. That's a 1 chain. And it's awkward to try to define it because it's not just that you have 2 sides filled. You may even have 3 sides filled. I guess you could have 3 sides filled. Like you could have a 3rd side here filled, right? It's not that necessarily that you have 2 or 3 sides filled and you create a maze. A long chain is any chain that contains at least 3 boxes. So I found that nowhere defined anywhere. I just realized after some time they're talking about long chains. They mean at least 3 boxes have to be covered. So that's a long chain. It's 5. And the other one that I had here is not a long chain. It's a only got 2 boxes right over here. So here's a solution. Kind of, it's a partial solution. So if I have an m by n set of dots, this is how mathematicians think. They don't think 4 by 4. They think, how can I generalize this to as many possibilities as possible? So if I have an m by n set of dots in the game of dots and boxes, and m and n are both even, for example, the default 4 by 4 box, then the first player can win if the number of long chains is odd. So instead of focusing on making those boxes, you're trying to focus on making the chains or keeping the other person from making chains, because you don't want the other person to have chains. Because the second player can win if the number of long chains are even. And
so it's just a number. It doesn't matter how long each chain.
It doesn't matter how long, so because like you remember that example I gave you where they had all the horizontal lines filled, yeah, and then they started alternating. It's this alternating idea that if you have an odd one, you are going to be the first one that has all the boxes filled, because you can leave 2 boxes behind, and the other person will end up kind of in a corner. Yeah. So that's the concept. So people are trying to write this down. Even these are formal. These are probably the best definitions now that exist. So I think in mathematics, there's this. I've been trained now in mathematics for so long, I can't even remember a time where I didn't think about math almost every day. So thinking, realizing that, it makes me feel very uncomfortable not to have a rigorous definition in front of me. And I bring this kind of thought process to other fields. So when I come and sit down with a physiologist and they say, sugar sweetened beverages are bad for your health, I'll start asking, what do you mean by health? Do you mean my weight? Do you mean cardiovascular disease? Tell me by definition what you mean, because health is just a loose thing. I don't like loose definitions. I want to see something very precise written down when someone's talking. In fact, I just had an interview today, and they were asking me about if sugar sweetened beverages are bad for you. I asked them, what do you mean bad for you? Bad for you in terms of weight? Bad for you in terms of cardiovascular disease risk? Be specific, and then I can start to answer those things. And then you can see it's an even odd game. If m and n, either one of the m's or n's are odd, then the first player can win if the number of long chains are even. And again, it's about filling in the boxes and being the person that gets to fill in the last set of boxes. So here's the strategy to employ. So you'll never get a 0 box situation. You'll still get that annoying little boxes, me has won, whatever that little message that you get at the end of it. You'll still get that. I guarantee you that one. But the idea is to stop any chain formation by stopping any of the, and so while at the same time you want to also stop box formation. So you can't just sit there and say, I'm just going to block chains, because if you do that, then you'll make a 3-sider, and then the other person will start filling in boxes. So it's a double thing that you want to think, a double strategy you want to think at the same time. You want to stop chain formation, and you also want to stop box formation. And this is harder to do because you're concentrating on stopping the person from making chains, and all of a sudden you see the things start to spread with a bunch of me's in there. So what I'd like you to do now is to employ this strategy so that you're now blocking the formation. You'll see the computer strategy is indeed to make a chain. They're not randomly putting down their pieces. They're actually trying to form a chain. And it was kind of hard to see the computer strategy when you're first looking at it, because it seems like there is some strategy, but it's very difficult to see what they're doing. They're trying to make that chain. So block them and see what happens. So on the 4x4, because if you go bigger, it gets a little easier. So try it on the 4x4. try it with yourself as first player, and then try it with yourself as second player. Because if you're second player, I think it's easier to win.